Can you say something?
Can you hear me?
Yeah, I think I also move a bit. And now do a dance.
So that's why you asked me to be here. Okay, cool.
Yeah, I think we're. Well, let me check if. Was iedereen binnen? Ja, nou, laat maar open. Okay, welcome everyone. Welcome back. Thanks for staying after the beer break. Welcome to our next speaker. Already a resident speaker because the second time he's been here.
Yep.
About container services and storing the secrets in them. So please
Yes.
give a round of applause for Jussi.
Cool. First of all, thanks for having me here. And the good news is that I'm not gonna actually show any slides. So it's only live demo kind of things, and well, if it fails, then it's even more spectacular, I think. Let's see. Yes, absolutely. I'm gonna share a couple of examples how to manage different secrets like passwords, API keys, whatever, when working with containers. And then I'm gonna hopefully have time to also share how do we, with the container platform, how do you actually can pretty easily manage even SSL certificates for you, for your different services. As said, mostly I'm gonna be showing things on the terminal, so please bear with me when I'm making lots of typos, so hopefully it's not gonna be too bad. How many are actually using containers already, even in development, production, in any kind of environment? Only a couple of ones. Okay, so couple of words about what are actually containers. So they are these sort of a sandboxed processes on Linux world, where you can pretty easily package your application with all your dependent libraries and basically everything that your application depends on, package that as one container image, and then spin up lots of container instances out of that same image, which pretty much gives you the 100% guarantee that whenever I spin something up from my container, you're gonna always have the same library dependencies, same set of files, same set of everything within the container. Maybe not the most accurate description of containers, but gives you the overall idea what are containers. The Docker guys would kill me if they hear this, but they are kind of virtual machines, but nothing like VMs. Kind of, but nothing like. Okay, that's about containers and what they are. So when you're working with containers, you basically have a couple of different options how to manage your different secrets, like for example in this example your MySQL password in your containers. You can of course pre-build that into your container image, but well, if you build it into the image itself, it's kind of hard-coded there. You cannot really take that out from the image. If you really want to take that out from the image afterwards, you have to do quite a lot of different tricky things to really get it out of the container. So even the cow says that you really shouldn't do this, because it's like basically like hard coding your MySQL password in your code. It's exactly the same thing, and all of our brains typically yell that don't do it, and you shouldn't really do it. Docker, when running containers, Docker of course gives the nice usability features, so you can actually pass environment variables when you launch the containers. So in this case, I could run the MySQL container and say when launching the container that okay, now this password is my secret password. And then when you run it another time tomorrow on some other environment, you could say that okay, now use some different password. Of course, it makes things a lot better, that you don't actually have these hard-coded passwords to give these IoT type of intrusion points like Antti mentioned in his presentation. But then again, when you're running single containers here and there, it's maybe manageable to do this by hand. But when you have tens of hosts where you actually run the containers, I'm 100% sure that tomorrow your passwords are not in sync anymore. So you really don't. This is not really an option for you when using things. So as said, it's a bit better way, yes, but really hard to scale and keep up and synchronize your configuration between different environments. Docker has also these environment files that you can store your basically secrets or whatever configuration in an environment file, and then pass that along to the either when running things manually through Docker run, give the environment variable, and then it injects all the environment variables into the container. So it gives you a bit more sort of manageability when you have things defined in one single place. And then of course it's easier now to ship this one N file between different hosts and different environments. But it still requires you to have some automation, some configuration management tools to really keep all the environments, all the hosts in sync. And then of course it has the unsolved problem of actual security. Where would you actually store this environment file? Because it has your database root password. You probably don't want to put it in GitHub where your other code are. Or at least if you put it there, use some crypting things like gitcrypt or something. But whoever has been using gitcrypt, for example, they know that it's actually a pain in the ass to use it. And thus we actually would, with many of these options, you end up in solutions that are either tricky to maintain or tricky to operate. And we know that if it's for the end user, if changing the password to my IP cam is too hard, I won't change it. Thus, we get these denial of service attacks. So we have to have something that's really centralized and something that's really easy for the end users to use and still be secure, at least secure enough to operate your different environments. So, pretty please, can we see something that could actually work this way? I'm going to show as an example how the container platform operates the secrets, how it actually works, and how it feels for the end user in the UI, in the terminal. But of course there are other similar solutions out there like the HashiCorp Vault and most of the container orchestration solutions, they provide something to manage your secrets also. Kubernetes has something. Docker Swarm will have something soon, and probably all the others has something also. So in container, we have this concept called master and agent. So agent is the one sitting in the server, waiting for instructions that okay, now launch some containers or something, do something, and the master has the brains and the state. So in container world, the master actually stores all the secrets, and when the master stores the secrets, the secret values, in this case the MySQL password, that's always encrypted using AES 256 CBC encoding, which should be, as far as I know, pretty secure. whenever the secrets are transferred between the different components, they are always transferred within the TLS encryption. So again, there's nothing exchanged in plain text in any step of the process. So that should be pretty safe to operate in even in most secure environments. But how does it actually work? As a kind of guinea pig application that I'm gonna show how to deploy, I have this Mattermost application. That's kind of an open source version of SaKE, more or less. And I would guess that all know what's SaKE. I guess I would say that yes, that like 80% of us are actually using SaKE for some purpose at least. In Container, you define things in this YAML configuration, and of course, what we are now today interested is these secrets. By the way, is it big enough? Can you read it? Okay, cool. So as part of your kind of service configuration, you can define that, okay, this service requires this and that secret. And you always refer to the secrets by name, of course. If it would be some random UID or something, we humans wouldn't be able to operate it. And the other option you have to give is that how does the container within, how does this secret get injected into the container? So what's the environment variable name that's given within the container to this secret? So it gives you really easy reusability of your secret. So now I can actually define my MySQL password only once and then reuse it across different containers, because I can kind of change the name how the container sees the exact same secret. Otherwise I would have to say that, okay, for MySQL the environment name is A, B, and C, and this other container actually needs the exact same value, but it uses the name foo or something. So you would actually end up in a lot of pain to try to manage these and sync up these between different containers and applications. And then of course so that was the definition for the actual application, so for the web app. And then for the MariaDB database, we actually have two different secrets. So one for the root password and then one for the database password for the defined database, which is in this example called Mattermost production. I'm not sure if it's really cool to call it production because it's not really production, but never mind that. So what I have to do now to be able to really deploy the application, of course I have to put some values for the secrets, otherwise the system wouldn't know what to do with it. So what I'll do is I'll just copy paste this one, hop to the terminal, see what's in my configuration. Nothing, as expected. Random enough. And what was the other one that's needed? This MySQL password. Having secrets management centralized like this gives you really the option to have this sort of a really random passwords, because nobody actually has to remember them anymore. So it's really good for the security point of view. We should have everything in place, so let's just deploy the whole thingy. Should be done in a minute or two. So what basically is happening now is in the background is that I have actually 3 different servers connected into the same cluster. So the container platform is creating the containers on each of these hosts as defined in the configuration file. So whoever has been working with containers pretty recognize that, okay, it's pretty much like Docker Compose files. And pretty much similar things happen in the background, but across different hosts with virtual overlay networking and a bunch of other stuff, which I won't go into today. Hopefully I won't get the demo effect. Let's see. Deploying things, the first time usually takes annoyingly long because I haven't optimized the Docker images because it's a demo thingy, and then now all the hosts have to pull in all the images from Docker Hub, and again, who's been working with Docker know that dependent on the day and time and phase of the moon and everything, Docker Hub is painfully slow at times. Let's see. Yep, good. So let's see that it really came up. I'll grab this IP and we should be able to see something. Ooh, no. Why? This is the demo effect. Yep, it just took a while to get everything up and running. Because I have auto-configured load balancer in between, so it took a few seconds to actually configure the load balancer automatically. So it's basically up and running with all the secrets. How long did I have? A few minutes only? Okay. So let's try if I can actually in 3 to 5 minutes to put in a SSL certificate on top of this, because of course we don't want to use anything on top of plain HTTP. So container actually has an integration to Let's Encrypt, which is the really cool new completely free and trusted certificate authority. So it really gives you completely free but still fully trusted certificates. So what I'm now gonna do is I'm gonna try if I can manage to get the certificate quickly. Not yet. Will soon. So what I'm going to create first is this sort of a challenge, because the Let's Encrypt provider has to, of course, figure out somehow that I really control the container.io domain. Otherwise, I would be able to get sanoma.something certificates, which is not cool. So it gives me this challenge that, okay, fulfill this challenge and I'll give you the certificate. So the challenge is that I have to actually create this sort of a TXT DNS record, which I'm going to do in our domain provider, and the value is given here. So let's copy paste that one. This is, of course, this step depends what DNS provider and tools you are using. Okay, cool. That's created, so let's try to get it first, get the actual certificate. It gives, well, DNS has these time to lives, and it takes a minute or two to actually have it in place across the world. Yes, now it works. So what happens in the background that our master talks to the Let's Encrypt API, and when it actually gets the certificate, it actually inserts it automatically securely to the container vault that I just showed. So the certificate is now securely encrypted in our vault. And now what I can actually do is I can grab this. Oh, bloody hell. Grab this secret name and inserted it into the load balancer configuration. Hopefully I remember how it actually works. And now, of course, we want to expose the standard 443 port for the actual traffic. And now when we redeploy the load balancer, we should have SSL encrypted traffic to our Mattermost application. If I didn't make any lots of types, but let's see. No.
You're connected on IP.
Oh yeah, yeah. I don't have the domain. Yeah, of course. Well. Yep. But as you can see, it's really now encrypted with a really trusted certificate and everything. I don't think it could be much simpler than that anymore. Any questions? I was almost in time.
And interesting to see that Jelmer spotted out the error as the first one, as our marketing intern. Any questions from the audience?
Touché.
No one. The NordCloud guys in the back are still puzzled by the whole thing. You have a question? You only have 10 steps left to figure one out.
Creating
Yeah.
that automatic renewal of the certificates. Yeah.
It's gonna be implemented soon. It's not yet there.
So it's going to be your feature or so the automatic renewal of the certificate, is it going to be container feature or let's say encrypt feature or both?
Both.
Okay.
So Let's Encrypt has the capability to renew it automatically, but we haven't it implemented on our side yet that it actually follows up the certificate, because we don't actually store anything about the certificate itself. We just whatever Let's Encrypt gives us, we basically dump it to the vault. So it would basically mean us to really have a look on the certificate and what's the expiration date, to really then start to interact with the Let's Encrypt API. But it's actually it shouldn't be a big deal to implement. A few hundred lines of code, more or less. But anyway, when you register with your email, like I did with my company email, so whenever my certificate is now getting old, it actually gives me, I think it starts to spam me like 10 days before. And then basically renewing your certificate would be one single command. And if the certificate would be actually updated now, the container vault actually notices that actually the value has been really changed, and that would actually then automatically trigger deployment of the dependent services. So the load balancer would actually automatically get new certificate into its configuration. So you still have to run one command, but renewing certificate with one command across your different variety of hosts, I would pay for that. Anything else?
Are you Tero? Your demo. Ah, yeah. Could you start setting up, by the way? We're a bit confused. Final question for Jussi? No? Okay. Then
cool.
thanks a lot. Please a round of applause. We wanted to give you the maximum amount of time to finish your demo. Kiitos. And I don't know if it was intended by Jelmer, but like the blocks have like a theme. So this is the container block. So again, well, not you, but we had a speaker from Red Hat before, talking about the container services. So